Hi everyone. This video is just going to serve as a really short introduction to R and RStudio. So as you can see, I have RStudio open on my computer here, and yours might look a little bit different. Mine's in dark mode, and you can kind of reconfigure where each of these panes are, but you should see the console and a tab for terminal, the environment, and a files pane. So if you see those, you're good to go. Okay, so in its simplest form, R is a calculator, and we can do R in the console here. Or we can use R to compute things in the console here. It can be a simple calculator. I can type in an expression, click enter, and then I get the answer, 3. 1 plus 2 is 3. We can also do more complex calculations like bed mass required operations. R is going to pay attention to the order of the brackets, for example. You can use the square root function. We can raise things to powers, and it will compute that pretty quickly. Now, those are just simple calculations, fairly simple calculations, but oftentimes what we want to do is store variables in R and refer to them later. We can do that by using this command. It's like a left-facing arrow, and we're going to assign a value to some variable. For example, let's say we have an age variable. I'm going to call it my_age, and I'm going to assign it the value of 28. Here, you can see in your environment, if you don't have that open, you can just click over here. We have the variable my_age, and it's given the value of 28. We can also confirm this by typing my age in the console, clicking enter, and we see that it does store the value of 28. We can do math to this. So say I'm really bad at mental math and I want to know how old I'm going to be in 15 years. Yikes, 43. Or maybe I want to double my age and to see that's 56. You can do any sort of math where my age, when R is going to evaluate the expression, it's just going to substitute in that value of 28. Now, we can also use this expression to store another variable. So say I actually did want to refer back to that age plus 15 variable. Maybe I'm going to call it my age in 15 years, and it's my age plus 15. I can see that value over here is 43. I can also type it in the console, and a little hack is if it starts to pop up and that variable that you want is selected, you can just click the tab button and it will show you. Or maybe I want to look at what it is for a different age. So let's say that I'm not 28, I'm 19 years old, and then I can reevaluate this expression, and it will be updated for 19 plus 15, which is 34. So in its basics kind of core, again, R is really a fancy calculator. So R doesn't just use numeric data, there's different types of data structures. So I'm just going to clear my environment here. It's just going to get rid of all those messages, and we're just going to start fresh. By doing that, I still have my variables in the environment. I just really cleared the history, and I can actually access it again by clicking the up arrow. So aside from numeric data, R also can handle strings, and strings are these types of numeric data that are, character data that are composed of characters. So maybe I want to have a variable called my name. I'm going to use the quotation marks, single or double, it doesn't matter. Just make sure that they match on either side. I'm going to assign that the value of Grace. And if I were to do the built-in R function type of my_name, it's going to tell me that it is a character. Whereas if I wanted to look at what type of data my age was, it would say double. And you may be like, why isn't that numeric? Well, double is a type of numeric data. So if you see double, for now, you can just kind of think of it as being numeric data. We can do operations on strings. We can even do longer strings that are like full sentences, like I love stat 545. It will save that whole sentence, spaces included. We're going to have a whole lecture on strings, so right now, just know they exist and we can do things with them, but we're not quite sure how to do them yet. Another important data structure in R are vectors, and they can store multiple values of the same data type in one sort of variable. So let's say that I wanted to look at data from the first 4 years of my university. Now, this is made up data, but let's say that I had 4 roommates my first year, 2 roommates my second year, 3 roommates in my third year, and then I hit the lottery, hit the jackpot, and I got no roommates in my last year. Maybe we want to save this all in a data structure called roommates, and we're going to do so by creating a vector. And we create a vector with this C function, which I believe stands for concatenate. And all we're going to do is write out the data that we want to store, separate it by comma. So I had 4 roommates, 2 roommates, 3 roommates, and then 0 roommates. Now, if I type of roommates, you may expect it to pop out, well, this is a vector. What it's actually going to tell us is what type of vector it is. So the data inside of the vector contains numeric data or doubles. We can, however, see that it is a vector by looking at the length. We can see that there are 4 values in that variable. So it has to be, well, it doesn't have to be, but it is likely a vector. And we can actually access each individual element of the vector as well. Let's say we wanted to know how many roommates I had in my first year. We can use these square brackets to index this vector. And if you're used to Python, please know that R starts indexing at 1. So if I want the first value of roommates, I'm going to put a 1, not a 0. And I can see that's 4. Maybe I want to see what the last value is, the third value. Maybe I want to look at the first 3 values. I can go from 1 to 3. So this is saying every single number, whole number between 1 and 3 inclusive, is going to give us the first 3 values. So we can access data within our vector. We can also do math on vectors. So let's say that I forgot to add myself and I want to know how many total occupants there were in our, I guess in the lecture I didn't use an underscore. We want to know how many total occupants there were altogether. Well, that would be the number of roommates in each apartment plus me plus 1. And it didn't pop anything out because all we did was make this new variable. We didn't call it to print, but I can see over here, and I can type over here as well, that is roommates plus 1. We will get more into kind of the math that we can do on vectors. We can do matrix algebra, really fancy things, but for now, we will leave it at that. And of course, there are more types of vectors. There's not just numeric data. We can store character data and we can do logical vectors. So let's take a really quick look at a logical vector. Let's say we want to know how many apartments had more than 2 occupants in it at any given time. Well, let's create a new variable, more than 2 occupants. And we're going to see which values in total occupants were greater than 2. And when we look at this, we can see that the first 3 values of this more than 2 occupants vector are true, and the last one is false. So that's indicating my first apartment was true. I did have more than 2 occupants. Same with the second and third, but not the fourth. And we can confirm that because 5, 3, and 4 are bigger than 2, but 1 is not. And a cool thing about logical vectors is they're actually encoded in R as zeros or ones, 1 being true and 0 being false. So if I wanted to know, okay, well, how many apartments did I have more than 2 occupants in? I can actually just call the sum function. And I can see that that number is 3. Again, we're going to get into all these sorts of functions. There's so many built-in R functions that we're going to come across in the course, but this is just a really cool one that I wanted to show you. And of course, I should backtrack a little bit. We can also check the type of this vector, and it's a logical vector. So that's sort of the basics of R, but that would be really annoying if every single time I wanted to do this analysis, I'd have to go line by line, click enter and run it. So what we can do is actually use an R script. And we can create an R script by going to File, New File, R script, and it's going to pop up here and it's just going to be untitled. So let's save this file. I'm just going to save it on my desktop for now, right here. And I'll call it roommates because that's the example that we've been using. And it's a .r file, so that means it's an R script. Now let's write out our code up here and let's actually start fresh. So let's remove everything from the console, that history, and I actually want to get rid of all the variables that I already made. So I'm going to clear them. This means that when I click this broom, I'm going to clear the environment. I can no longer access those variables unless I run my code again. That's fine because we are honestly going to start over. Let's write out that roommates code again, but this time in the R script. So if I write this and I click enter, nothing happens because R is letting me write out multiple lines of code without running them. I can run them after. And then let's say we want to, I'm just kind of copy and pasting this code. We want to calculate the total occupants, and then let's print out the total number of occupants. Whoops. So again, nothing has run yet. Let's save our code. That will turn white. And then there's a couple ways to run it. You can highlight the whole thing and click the run button, or you can click Command Shift or Control Shift and enter, depending on if you're on Mac or Windows OS. I'm just going to do the highlight and run. And you can see it actually sends the code line by line down to the console. And it outputs what I wanted, the total number of occupants. It also created variables in our environment. Now, if I were to share my code with someone, I could send this R file and they're going to get the exact same output as me. So I can run everything again. I don't have to type anything. I just have to run it and I get the same values. So for code that you want to rerun again or build on, it's really important to write it in a R file. Now I can also inspect things in the console. So say I want to save my code, the bones of the code, but I want to check a couple of things. Let's make sure that the length of total occupants makes sense. Yep, it's a vector of length 4. But again, I'm not actually editing this R document. The console is really useful for kind of snips of code that I want to double check as I'm doing my analysis. However, if you do create a variable in the console, whoops, let's just make a kind of silly one that's total occupants times 2. R doesn't care whether or not I wrote it in my R script or on here. It will save that variable. So just be careful that when you're doing things in the console, you're not overwriting anything or making new variables that might mess up your analysis. So it's really good practice to every now and again, clear the code, rerun it, and make sure that everything is running as expected. And again, always save your code. So this is really the basics of R and making R files in RStudio. We're going to talk more about reproducibility and R Markdown next week, but I thank you for watching this video.